Now, are there any questions in this? Let's just take it in order. Does anybody need to see 1, 2, or 3 worked out? Okay, these were just straight Pythagorean theorem. A squared plus b squared equals c squared. Some of them were looking for the hypotenuse, and some were looking for a leg. All of the questions on the quiz tomorrow, you must leave in simplest radical form when you're using the Pythagorean theorem. Yes? Okay, so for number 3, this one we're looking for a leg. So I'm still going to go ahead and plug it into a squared plus b squared equals c squared. The 4, I'm going to say, for my formula, I'm going to say the 4 is the a. The 8, you always have to label the hypotenuse as the c squared. So the 8 would be my c. And then in the formula, I could say the x was supposed to be the b. So I'm going to go ahead and do 4 squared plus x squared equals 8 squared. 4 squared is 16. 8 squared is 64. I'm going to subtract here. X squared equals 48. 48 is not a perfect square, so I need to break it down. So the square root of 48, I need to do a factor tree. So I can factor it into, it doesn't matter, you could go back and do any factor you want. I could do 6 and 8. For me, 16 times 3 would be the fastest. However, probably more common, students would use 6 times 8. Keep going till it's prime. So 6 becomes 2 times 3. 8 becomes 2 times 4. I'm still not at prime. I like to keep rewriting my primes so I don't forget about anything. And then the 4 is 2 and 2. Now that I have all prime numbers, I need to go back and look for pairs. So I have a pair of 2's over here. I'm going to pull a 2 out of that because it becomes a perfect square. I've got another pair of 2's. I could group these 2 together, and that 2 comes out. The poor 3 doesn't have a pair, so it's going to stay underneath. Any numbers that come out, multiply them back. Any numbers that remained behind that didn't have a pair, you would multiply those together. In this particular problem, there was only the square root of 3 left. So the square root of 48 in simplest radical form, the exact answer would be 4 square root 3. Any other ones from 1, 2, or 3? All right, let's look at the next group. How about 4, 5, or 6? Still using Pythagorean theorem, we just have to interpret when c squared is bigger or smaller. Memorize that. Do not get confused tomorrow. I see too many times students know what to do. They know to square the 3 numbers, but then they forget. What do I do with the results I've gotten? So just remember, when c squared's bigger, it's obtuse. C squared smaller, acute. C squared equals a squared b squared, it's right. Then the next group was the special right triangles. Anybody need to see 7, 8, or 9 explained? Yes, 9. Number 9. Okay, so for number 9, now at first glance you're going to say, wait a minute, that's got the square root of 2. Isn't that supposed to be for a 45, 45? However, it can have a root 2 when it's a 30, 60, 90. It's still a number. So let's go ahead and fill in what it should have been. So over here would have been 30. Across from the 30, we're memorizing this as being A. Across from the 60 is supposed to be A with square root 3. And then the 90 is supposed to be 2 times A. Now, what I need to do here is to figure out what A equals. So I'm going to set 2A equal to 10 square root 2. So I'm going to set this equation up to solve. I'm going to divide by 2. And my A value is 5 square root 2, which is the side that's the x, which is the side that was across from the 30. So this is 5 square root 2. Now to find y, I'm going to take what this A is, and I'm going to put it right here. So now I'm going to take that and put 5 square root 2 for the A. And then I also still have to put the square root 3 as the part that I memorize. What I need to do is I can only work with the things that are underneath the square root together and things that are outside. So the two things that are underneath the square root are what I can multiply together. So this final answer here for y is going to become 5 square root 6. These are not pairs, so all I do is multiply them back. Anybody need to see one from 10, 11, or 12? Okay, all you're doing here is finding the product. You're going to multiply the two numbers and then square root it. Again, I don't want a decimal answer. I want it left in simplest radical form. I'm going to want it exact. Now, 13, 14, 15, this is where we need to use those two proportions, the geometric mean altitude theorem and the geometric mean leg theorem. Anybody need to see 13?
Can you explain the similarity statements?
I will do that too. I can go ahead and pull these apart. You will also have to write a similarity statement. So, for example, let's take a look at 13 and let's see if we can come up with a similarity statement for this one. So here is my original right triangle. Now, what might help you when you go to pull these apart to get your similarity statement, if it helps you to go ahead and label this one as this AC, you can see that this is the hypotenuse. It's across from the right angle here. And then it might help you when you go to face it in the same orientation. BC looks like it's my shorter leg. And then AB would be the longer leg. So if I want to face them all the same way, this might help me when I go to flip it over. So this one I'm sort of just flipping up. So the B is the right angle, C would have been up here, and A would have been over here. Then when I go to pull out the next right triangle that the altitude has just created, so my altitude is right here. And again, it's now made this little one over here, so I can pull that one out next. The 4 is my shorter leg. My longer leg is this one over here. And then this would have been my hypotenuse. So if I go to redraw this one, and again, try to face it in the same orientation. Now the right angle is at D. The shorter side is the CD, and then B would have been over here. So shorter leg, longer leg, hypotenuse. And then if I do the last one, let's do this one in pink. So that it's over here now. And again, this time my shorter leg is here, and then the 8 would be my longer leg. So this one's already sitting in the same orientation, so this one's a little bit easier. So D, and then B, and then A. So shorter leg, longer leg, hypotenuse. Then when you go to write a similarity statement, if you decide to go hypotenuse to shorter leg, all you're going to do is go around this way. Or around this way for all of them. So like for the first one, it would be triangle ACB. And then the next one, BCD. And then for the pink one, ABD. Now, if it's going shorter leg, longer leg, hypotenuse, whatever order that's on the test, you've got to match it, just like in the homework. So remember how in the homework they started it and you had to match it. Have the first one already written for you. You're going to have to match the other two triangles to the order it went in, just like you did in the homework. Okay. Everybody good there? All right, so you will have to write a similarity statement as well. So again, always keep in mind that the review doesn't always encompass every type of question. This is why it's important you always go back, review your warm-ups, your notes, and your homework. All right, anybody need to see 13, 14, or 15 worked out? I know I already did 15 in the other video. All right, what about 16? All right, so for 16, whenever you go to buy a TV in real life, if you go to the store, the way that they show you the TV, like if it's a 55-inch TV or a 70-inch TV, it's not the horizontal measurement or the vertical, it's that diagonal. So from one corner of the TV to the other, that's how they tell you the size of your TV. It's basically the hypotenuse. So what we need to do here, it says television sets are measured by the length of their diagonal. You want to purchase a television that is at least means 40 or bigger, should you purchase a TV that's shown. So what we need to do is do a squared plus b squared, and after we square and add them and then square root it, if that answer is bigger than 40, then we want to buy this TV. So let's try it. So we would do 36 squared plus 20.25 squared. So when I do this, and this would be a word problem that you would be using your calculator for. And again, when you're using your calculator, and if it says to round your answer, do not round it mid-problem. You wait until you're all the way finished, and then you'll round at the very end. So when I do 20.25 squared, I'm going to get a long decimal here. I'm getting 410.0625. Now, I'm trying to see, basically, what I want is an obtuse triangle. I'm trying to see if this is bigger. So what I'm trying to do is add these two together now. 1296 plus the 410.0625. And I get 1,706.0625. I need to square root that because basically what I'm looking for is the c squared. Once I square root that, I get 41.304509. So because I can see that this number is bigger than 40, yes, I would want to buy this TV because it is bigger than a 40-inch TV. Okay, so you were just basically looking to see if after you squared the length and the width, if it gave you a number that was going to be bigger than 40 inches. And then the last one, again, you're not going to have a question similar to this, but this is a good way to look to see how you could identify a special right triangle. So for this one, it says, are any of the triangles special right triangles? So let's go through and take a look at each one. Well, the first one's easy to see. I've got two congruent sides here, which are the legs. So when I have two congruent sides, I also know I have two congruent angles by my base angles theorem back when we learned about isosceles triangle. So if I know that out of the three angles of a triangle, they always add up to be 180. If I subtract out the right, that tells me I have 90 degrees left for the two angles. And because they're congruent, when I divide 90 by 2, each of those angles are 45. So this is a 45, 45, 90 special right triangle. If it asks you to find the length of the hypotenuse, remember you're memorizing this as a square root 2, and this would have been a, so it's just 4 square root 2. So A is a special right triangle. Again, it's the 45, 45, 90. Then for B, I see a root 3 here, so that's going to be a clue for me that this is going to possibly be a 30, 60, 90. So I do have the 90. So, and I also have memorized that the side across from the 30 was A. The side across from the 60 is whatever A was with root 3 behind it. And then the hypotenuse, I'm memorizing this as 2 times A. So 2 times 3, and this hypotenuse would be 6. So this is a special right triangle. It is a 30, 60, 90. For C, I can see here that my hypotenuse is whatever A was with root 2 behind it. So this tells me this side over here is also 6. Making this the 45, 45, 90 right triangle. Now D, this is actually a Pythagorean triple. It's the 3, 4, 5 triangle. However, the 3, 4, 5 triangle isn't necessarily a special right triangle. It does not satisfy those rules that you memorized. So this is a right triangle, but it's not special. It's a Pythagorean triple though. And then the last one, this is the hypotenuse, which we're memorizing as 2 times a, because if 5 is a, then double that would be the hypotenuse, and then this side would be a root 3, so this would be 5 square root 3. So this would have been the 30, this would have been the 60. So this, yes, this is a special right triangle. It's a 30, 60, 90. Now, the next part said, which ones are similar? Well, if you reach back to chapter 8, remember we learned 3 shortcuts to prove triangles similar, and the easiest one was angle, angle. So because triangle A and C are both 45, 45, 90s, and they both have 2 congruent angle pairs, they actually have all 3, I will say that triangle A is similar to triangle C, and then also the 2 30, 60, 90s. So B and E are also similar triangles because by AA, these are similar triangles because they have congruent angle pairs. And now to find the altitude lengths of B and C, if I redraw the triangle down here, so this is sort of the picture that's created in 9-3. So if I take my triangle B here, the right angle was here. We were told that this was 3 square root 3. This side was 3. So this was the 30, 60, 90. Once I draw this altitude in here, I've now created my right triangles, my 3 of them. The one I'm going to focus on is going to be this one over here. This is the one I'm going to use. So I'm going to redraw it over here to the side. The altitude is the green. So this is my altitude once I've pulled it out. Now, I've got the 60-degree angle here from before. Then this would have made this one 30. The 3 in this triangle is the hypotenuse. This is equal to 2 times A. Remember, this side across from 30 was A, and across from the 60 is A square root 3. So I need to find A, and then I'm just going to plug it in over here to get my altitude. So I'm going to divide both sides by 2, and my A value is 3 over 2. Now I'm just going to take that A value, and I'm going to put it right here. So the altitude of this triangle is 3 over 2 square root 3. For the other one, so this was the altitude for B. Now I'm going to do the altitude for C. So C looked like this. It had the right angle up here. It had 6 square root 2 here and a 6 here. Once I draw down my altitude, again, I'm making a smaller right triangle here. Now, also, I knew that this was the 45, 45. So this one's 45, this one's 45. So now when I pull this purple one out, and this is also a 6 here, and this is 45, so this one would be 45. Now, in order to find this altitude here, I need to memorize the relationship of the sides of the 45, 45. This is A, this is A, this is A square root 2. So to find A, which is the altitude, I need to solve this equation. So divide by square root 2. That cancels. A is equal to 6 over the square root of 2. I need to rationalize this. So I multiply the top and the bottom by square root 2. And this gives me 6 times square root 2 over 2. And then I can simplify the 6 and the 2. And the altitude is 3 square root 2. You will not have a question like 17 on the quiz tomorrow. You will not have this type of question for your word problem. Any other ones from the review that you want to see worked out? Yes.